Hi there and welcome to another 𝗵𝗽𝗀𝗀 tutorial. In this video we're going to build a bar chart which uses data from our Django backend to create a plot which is rendered in the front end, and we'll use the Bokeh library to do this. And we're going to use HTMX to give users the ability to filter by date or filter how many bars they want to see in the chart. For example, if they select 1978 from this data, we'll see the GDPs displayed for that given year. And if we select the top 50, you'll see the top 50 countries on that year. And these are all configured with HTMX. So when we change these two fields, we will update the bar chart in place with no refreshing of the page. And we're going to use a library called Bokeh on the back end to generate these charts. And these can return dynamically HTML and JavaScript that you can embed in your Django templates to show the charts. So we're going to see how to build all of that in this tutorial. So there's a starter project on GitHub here, and the link will be in the description for that. So you can clone that repository and then you can install the requirements. And the requirements.txt file contains these requirements. We've got Django, Django extensions and Django HTMX, but we also have this Bokeh library, and I'm not sure if I'm pronouncing that correctly. But basically this is a graphing and visualization library in Python. It allows you to make charts from your data. We're going to use Bokeh in this project. Other than that, we have a GDP analysis, that's the project folder containing our settings, and we have a GDP application within our Django project. Now what we're going to start by doing is we're going to look at the data we have. Now there's a data folder within the starter code, and that contains a single JSON file. And if we look at that JSON file, we see that we have certain fields in our data. We have a country code, we have a country name, a value, which is the GDP, and we also have the year. Now this data set has data for all years from 1960 for some countries up to 2016. We're going to see that a little bit later. So what we're first going to do is create a model, a Django model that can represent this data. So we need these fields: the country code, the name, the value, and the year. So let's go to models.py and we'll start by defining the model for the GDP. So it's going to be a class called GDP, which will inherit from the models.model. And our first field is going to be the country, which will be a car field. And we'll say max length equals 100 for that. And the second field is the country code. Now this is a shorter field. It's going to be a car field, and the max length will be, let's say, 4 for that. If we look at the JSON data, you see that the country code is typically 3 letters, so that should be sufficient here if we say max length equals 4. We also have the year, and the year is going to be a models.integer, or let's say a positive small integer field. And finally we have the GDP itself, and that's going to be a models.float field. And finally we'll define a stringify method, a _string method, and that will simply return the name of the country, self.country. So that's our model. What we need to do now is we need to make the migrations and then migrate the changes to our database. So I'm going to run a command, python manage.py make migrations, and that should reflect the changes. That will create the migration for our database model that we've just created. And after making the migrations, we can run the migrate command, and that should actually create the database, and it should create all the tables within the database. And once the database is created, we want to actually populate it with data from our gdp.json file. So what I'm going to do is, we've got within the starter code a manage.py command called populate.py, and at the moment this is simply not implemented. So we're going to write some code that is going to import the data from this gdp.json file into our database using the model that we've just created. So let's get rid of this not implemented error, and I'm going to import the GDP model from gdp.models. Let's import that new model that we created. And what we want to do now is we want to add these GDP objects if they don't already exist. So I'm first of all going to check if there are any GDP objects in the database. So if gdp.objects.count, if that equals 0, then this line will evaluate to false, otherwise it will be true. So we want to add these only if they don't exist. So we're going to say if not gdp.objects.count. And what we're going to do now is we're going to set a path to our data file, this gdp.json file. So I'm going to say data file, and we're going to use the settings.base directory. And the base directory is actually the root directory of this whole project, this one here. So we have a data directory within that base directory, and we're using pathlibs notation here, the syntax. and we go to the data directory, and within that directory we have a gdp.json file, so gdp.json. So that will set up a path to our data file, but we do need to import the settings. So I'm going to say from django.conf import settings, and that will give us access to our project settings. Now we have the data file, we want to load it in, so I'm also going to use the JSON module here. Import JSON. We're going to open this file here with open data file, and we open it in read mode as F, and we can load in the data with the json.load command, and we pass the file handler to that command there. So json.loadf, that will give us our data. Now what we want to do is get only the data for countries. If you look at the JSON file, you see that we have some regions here, the Arab world for example. Now the first country in this data happens to be Afghanistan. I have checked that, and once you get to Afghanistan, everything else in the data file is a country. But before Afghanistan, everything is regional, like Arab world, or actually there is some data as well for the whole world. So we want to get rid of that and only keep the country data. So we need to filter out everything from this data that occurs before Afghanistan. So I'm going to use a very cool function called itertools.dropWhile to do this. So what we need to do is, at the top here, we're going to import the itertools module, and we can use the dropWhile function here to drop all of the records that occur in this data before we reach Afghanistan. So in order to do that, we're going to define data, and we're going to use itertools.dropWhile. And the dropWhile function, as you can see here, it takes a predicate, which is going to be a lambda function in this case. So we're going to take each record and we're going to say drop all the records while the country name is not equal to Afghanistan. The second argument to dropWhile is going to be our actual iterable, which is the data we got from the file up here. So we're redefining data here, and we're saying drop all of the records from the data that we loaded from the file while the country name is not equal to Afghanistan. So when it hits the first instance of Afghanistan, it's going to basically stop this call and return everything after that. So this function here, itertools.dropWhile, it's just a handy way to remove everything from a list up until you finally, this predicate evaluates to false. When it finally reaches Afghanistan, it's going to stop and it's just going to return everything after that. So now that we have that, we can actually iterate over that. But first of all, let's set up an empty list of GDPs. And then we can say for D in data. So now we're iterating over every dictionary within our JSON file. So for D in data, we are going to append to that GDPs list, and we're going to use the Django model that we created, GDP. And to that GDP model, we need to pass in the set of fields that we defined. So one of them was country, and that's going to be equal to D country name, and that comes from our gdp.json file, this country name here. So we also need the country code, which is going to be country code, and that's going to be equal to D country code, and year is going to be equal to D year, and finally the GDP is going to be equal to D value. And in the JSON file, the GDP is actually specified with this value attribute. And finally, after this for loop completes, we're going to have a GDPs list that's populated with model instances, and we can use the gdp.objects.bulk create method, and we pass into that the GDPs list, and this will create all of these in the database. Every GDP instance that we've got in our list, it's not currently saved to the database. When we execute this line, it will persist that data to the database. So with that, we can now run the script python manage.py populate, and that should populate our database with records. And if we inspect the SQLite file, and I've got an extension here that can do this, open database, and in the Explorer we should now see we have a GDP table, and that is populated with these records. And you can see that Afghanistan is the first value in the database table, and that's because of that dropWhile function. So that's all worked quite well. So now that we've got that, we can start building out the URL, the view, and the templates to show the charts. So let's now build out our view to define a chart. It's going to be a bar chart that shows the top 10 countries by GDP. So let's cross over to views.py. Now we have a very simple index view here. It only renders a template. What we now want to do is we want to actually generate bar charts from our GDP data. So we're going to walk through this. First of all, we want to define which year we want the data from. What we can do is we can get the maximum year in the database, and that's going to be using the GDP model, gdp.objects.aggregate. And we want to get the maximum year in our data. So I'm going to do a couple of imports here. Let's start by importing from django.db.models. We'll import the max function. This is a function or a model that you can use with the aggregate method to actually get the maximum over a column. So we're going to set the max year, and it's going to be the maximum of the year. The year, of course, is a field on the model. So what we're saying here is that get the maximum value in that field. We also need to import the GDP model. So from gdp.models import GDP. So we're going to pass the year from the front end to the back end later in the tutorial, but for now we're going to define the year that we get the data from as going to be request.get, and we are looking for a query parameter called year, and if it's not there we'll provide the default value, which is this statement here. So basically if there's no year provided from the front end as a get parameter, then we will default to the most recent year in the data set. We're also going to do something similar to get the number of countries we want to show in our bar chart. So I'm going to define a count variable here, and it's going to come from the front end from a get request with the key name of count, and if it doesn't exist we provide a default of 10. So we want to show the top 10 bars if nothing is provided by the front end. So let's now get data out of the database for these GDP objects, and we can see why we have these variables here when we do this. We're going to define a GDPs variable here, and it's going to be gdp.objects.filter, and we filter down by the year provided, which remember will be passed in, and if not, it will be the most recent year. So we get all of the GDP data for whichever year we're interested in, and then we're going to order by the GDP, and that's basically going to take the GDP field and it will order from smallest to largest the returned query set. And because that's from smallest to largest, we're going to reverse that as well. We're going to get the largest first, and we can use the .reverse method to do that. And finally we can index in and get the top count. This is the number we want to get. Usually it will be 10, but that will be able to be changed later on. So we index in and we get the top n from the query set for the GDPs. So that line will give us some Django models in a query set. We're now going to perform the necessary setup to define these Bokeh charts. So let's extract the country names and the GDPs from this query set, and we're going to use a list comprehension to do that. It's going to be d.country and d.gdp for each record in our query set, each model. And now that we have these two lists, we can set up something called a column data source. So let's cross over to the Bokeh documentation, and we have this page here called providing data. Now there's many ways you can provide data. You can use Python lists, you can use NumPy arrays, you can use pandas data frames. Under the hood, usually this library will use something called a column data source. It's kind of similar to a data frame or even an Excel spreadsheet where you have particular columns that have names, and this is what this particular construct provides to us. And you can see an example down here. We have a data dictionary with two keys, and we can pass this dictionary as our data to this column data source, and we're going to see how to do that right now. So let's define a column data source, and it's going to be column data source, and we do need to import this data source. So let's go to the top here, and I'm going to do 3 imports from this library. We have a column data source, and we'll come to the other 2 in a second. So to this data source we pass a data argument, and it's going to be equal to a dictionary. I'm just going to copy the definition here, and it's going to be the country names and the GDPs. These are going to be the 2 fields within this dictionary. So that defines this column data source. Now we need to actually create a figure, which is going to be the actual visualization. So we'll set up a variable called fig, and it's going to be equal to figure, and we pass an X range. Because this is a bar chart, we're going to set the country names on the X axis on the bottom, which we've got here, and we also want to set a height for this chart. So height's going to be, let's say, 500 here, and we're also going to pass a title, and I'll use an F string here, and it's going to be the top n GDPs for the given year, and these have these default arguments, the maximum year and 10. So we will be rendering this title out at the top of the bar chart. It's going to be the top n GDPs and in brackets the year. So That's our figure. We can then call functions that will render different visualizations, and the one we're going to use is called vbar. This is a vertical bar chart. So the bars will go from the bottom up vertically, and that's what we want for this chart. And we're going to pass a source equal to our column data source that we defined on line 24 here. And because we use that data source, we can use these names here, country names and country GDPs, to define our X and Y data. The X data is going to be country names, and the Y data is going to be the country GDPs. And finally, we can define the width of the actual bars in our chart, and let's just say 0.8 for that. So that will create a vertical bar chart figure. And this figure instance is actually imported from the plotting module in Bokeh. So if we go back down here, what we can now do is use the components function that we've imported from the embed module. If we cross to the Bokeh documentation, we have this other page here about embedding Bokeh content. And the one we're going to look at is this components function. And this components function, which you can see called here, you pass in the figure as an argument, and it gives you back a script and an HTML div. And the div contains the actual chart, and the JavaScript is in the script. So we can actually call this function, and we get back a script and a div, which we can then include in our context and show in the template. And that's exactly what we're going to do just now. So if we cross back to our view function, at the bottom we have the figure. I'm now going to paste a bit of code, and it's going to use the components function. It's passing the figure in, and then I'll set the context dictionary that contains our script and our div. And all we need to do is add the context to the render function. And now our index.html template will have access to this script and the div. So if we cross to index.html, at the moment I have a 𝗖𝗵𝗽𝗀𝗻 tag. Let's get rid of that. And I'm going to add a paragraph tag. That's going to be at the top. GDP by country, just to give the user some information. And then what we're going to do is we're going to render out the div, and we use the safe filter here to do that. And we also render out the script, and we will call safe again here as well. So let's now run the server, and we'll see what this looks like on the front end and if it works. So if we refresh this page, and we're getting this error, field year expected a number, but it got this dictionary. So that's my mistake. If we go back to views.py, and it's this statement here, this will return a dictionary, and it's keyed by whatever you provide as an argument here. So we can get that out of the dictionary with that syntax here. The aggregate function for query sets, it will return a dictionary with all of your aggregate results, and we can get the key from that dictionary using that syntax there. So if we refresh this, we should now see another error here. So unexpected attribute y to vbar. Let's cross back to our file, and actually it turns out that the y parameter here, it should be top. Because we have a vertical bar chart, we are specifying what values we want to be at the top of the bar, so that the library knows how large these bars should be. And when we refresh the page, we don't actually see any charts, and that's because I've missed an important step. And that is, if we go to the embedding content page, to actually embed this content, we need to include some JavaScript files. We have the Python library, which we're using on the back end in this view here, as you can see from the imports, but we don't actually have the script tags that we need for generating these charts. So there is a JavaScript component to this library, so you need to include that, and we're going to do that in our base.html file. So if you copy paste this code here from the embedding page, and you paste it into the bottom of the base.html file. This is our base template that the index extends, as you can see here. Put that in the bottom, just in the body tag at the end, and that should now render our chart with no issues. So if we refresh this page again, we now see a bar chart displayed on the page, and it's got the top 10 GDPs for 2016. That's the default year, remember the maximum year in our dataset. And this is a basic bar chart. We can improve the styles a little bit, and I'm going to take a minute to do that. So first of all, I want to center this title and make the font size a bit bigger. So if we go back to our view, so where we have the figure, we can set some attributes on that figure, and one of them is the figure.title.align, and we can set that to center. And we can also set the title's text font size, and I'm going to set that to 1.5 EM. And if we refresh the front end, you now see that the title is centered on the chart. So now that we have done that, we're going to fix this at the bottom here. We have some of these labels crossing the other ones, so it makes it hard to read. I'm going to orientate this slightly differently so we can see these better. So what I'm going to do is I'm going to do at the top of the views.py file, I'm going to import the math module from Python's standard library. Import math. Down here I'm going to set the figure.x-axis dot major label orientation. This is a math.py divided by 4. So what that's going to do is it's going to, as you can see with this effect, it's going to orientate the labels slightly differently so that they're more legible, and you can see the different countries and they don't overlap. So now you can see quite clearly that the USA is the highest GDP in 2016, followed by China, Japan, and so on. The final stylistic change I'd like to make is I want this to display numbers, not scientific notation. So what I'm going to do is add this here. I'm just going to paste this figure.y-axis.formatter, and it's using a numeral tick formatter. And this particular format here will show this in millions, billions, or trillions, whatever the unit is. And we need to import that from the models module. So if I save that and we refresh, we should now see that we have more legible here. It's 15 trillion, 10 trillion, and so on. So the y-axis labels are slightly better. And that's all the styling I really want to do. You can play around with the styles if you want. There's a page in the documentation dedicated to that, and I will link that in the description of this video. Now the next step I want to do is I want to give users the ability to actually customize the year and the number of bars that they see on this chart, and we're going to use HTMX to do that. So first of all, I'm going to define a little drop down that allows the user to select the year, and we want the user to be able to select a year from the minimum year in the dataset to the maximum year. And in the views.py file we already have the maximum year, so I'm going to copy that and we'll paste it. The minimum year is going to be very similar. We'll use min here, and that's the key name, so we need to paste that in here. And finally we change the max function, which we have from Django, we change that to min, and we'll use that here to get the minimum year. That gives us a range. We can generate that range and add it to the context. So let's add a new key called years to this context, and this is going to be equal to a range statement, and it's the range between the minimum year and the maximum year. So I'll just copy that, range between the minimum year and the maximum year. And because the range statement is not inclusive of the second parameter, we will add 1 to that so that we can get the final year as well. So now that we have the years in the context, we can go back to our index.html file. I'm actually going to paste this content in here, and basically this will use Bootstrap's column system to show the chart in a column 10, so the majority of the page will have the chart, and the latter 2 columns will show these drop downs. And we have a select element which loops over the years in that context that we've just defined, and it shows an option for each of the years that we have. So the only other thing we need to do is, because we're now going to use HTMX, I've created a partial here. So we need to create this and actually render the chart in that partial. So we'll create a new file, and it's going to be gdp bar.html, and the only thing this file is going to do is show the div, and we use the safe filter, and similarly the script, and we also use the safe filter there. So if we now go to the front end, we should see that we get this drop down here that has all the years between the minimum year 1960 and the maximum year 2016. So that gives the user the ability to select a year, but nothing will happen at the moment. Now is where HTMX is going to take over, and we're going to add some attributes to this select box here. So I'm going to format this a little bit so we can see this better. We'll get all these attributes on new lines, and we're going to set up a HTMX get request. So it's going to be hx get, and we're going to use the URL template tag. And it's going to be the index URL, which is basically it's this view here that we are already working in. We're going to send the request to the same view, and that view is going to return HTML that we want to swap into the DOM. So I'm going to set an ID here, and this is going to be equal to bar chart, and we will now set that as our hx target. So the returned HTML we want to set to be swapped into this div here, into the inner HTML. So we're going to return the partial, which will replace what's there by default. So with that, we can now go to our views.py, and within the view we are returning the whole index.html, but if it's an HTMX request, we want to actually only return the partial, which is the templates partials GDP bar.html. So we're going to use the Django HTMX library, which is going to be linked in the description as well, to do this. It's already installed in your project. What you need to do is add Django HTMX to the installed apps. So let's go to settings.py, add Django HTMX here, and finally we add a middleware which we can get from the documentation, paste that into our middleware setting, and this middleware adds the request.htmx attribute to Django's request object. So we're going to use that now. If request.htmx, then we will return render, and we will return partials / GDP bar.html, and we pass in the same context. So what will happen now is when we select a year, instead of returning the whole page, we will simply return the actual partial that contains this chart here, and that will then be swapped into this div here with that ID, and it will replace what's there by default. So let's see if that works now. And if we select another year, 1971, you see that it actually now updates accordingly, which is quite interesting. 1960, you see we have the top 10 from 1960, and the title, because it's referencing that variable in the view, it actually reflects that change. And you can also see that as the year changes in the previous years, like 1960, the GDPs are a lot smaller, 500 billion, compared to the modern years where we have trillions and trillions of dollars. Now we're going to add a second option that the user can select here, and that's going to allow them to change the number of bars they can see in the chart. And underneath our select box, we're going to paste in an input field here, and it's going to be of type number, and it's going to define how many bars to show in the visualization. And we want to set the value of this to a count that we define in the template context. So we're going to add count to the context, and that's a very simple line. Count equals count, and remember we're getting count from the get request up here, and it defaults to 10. So if we go back to the front end, and we see we have this count option now, and if we change that, it will work, but if you look at the top here, you can see that it is actually refreshing the whole page, and that doesn't happen for the HTMX driven selection here. That doesn't refresh the whole page, it just replaces the chart. So we're going to set up HTMX on this count here, and it's very similar to the above. In fact, it's exactly the same. I will copy these attributes and we can paste them onto the input. And this one has a name of count, so on the server we're going to get this here, and we're going to extract it from the get request. It's got that key name of count, so if we change that from 10, it will be some other value, and we're going to use HTMX to return the partial with the new chart. And we're also going to remove this form element here. We don't actually need that in our front end, so if we remove that, we should now see that when we change the number field, we don't actually refresh the page. So if I now select 5 here, we are dynamically replacing the chart with HTMX, and there's no refresh of that page. However, there is an inconsistency here. When you change the year and then you change the page, it's actually going back to 2016. So we're going to use HXVals to attach the value of the other attribute as part of the request. So to the input number, we're going to use HXVals, and we're going to attach the year, which is defined up here. This is the name of year. So the key we use is year, and we get the value of the selected option within our select box. So that code will do that. Document.getElementById. We get the select ID here, select year, and we attach the value. And we can do something very similar for our select box here, HXVals, and this time it's the count that we're getting. So we get the element with the ID of count, which is our input field here, and we get the value of that, and that will attach that to the request. And what we also want to do is we want to change the value of 1960 to what is actually selected by default. So in order to do that, we're going to go to our context again, and we attach the year that's selected. So year selected, and that's going to be equal to year, and this is defined up here. This is the request.get here, and it defaults to the maximum year in the data. So we've got that year selected in our context. What we want to do is make sure we have selected the correct option by default. So options have a selected attribute that you can use, and we're only going to use that if the year selected is equal to the current year that we're iterating over, and that is given here in this here. So for each year in our data, we will see if the year selected matches that year, and if it does, we will add the selected attribute. And we need to end the template if statement here, and that should now, when we refresh this page, it should show the correct year by default, which is 2016. Now if we go to 2001 and we change this to 5, we see that it's maintaining the correct values, because if you look at the requests that are being sent here, it's actually attaching the correct value rather than defaulting back to the default, which is defined in the views.py file. You can see the default here is the max year and it's 10 for the count. So we've now fixed that problem. The last thing I want to do in this video is add a hover tool to our chart. Now Bokeh gives you access to a hover tool model and you need to import it. So in views.py we will import the hover tool from bokeh.models, and down at the bottom here we're going to add this hover tool to our figure, and we use fig.addTools to do that, and we can pass our hover tool to that function. Now we need to define tooltips here, and I'm going to set up a variable called tooltips above, and this is basically what is shown when you hover over each of the bars. And I'm going to paste these tooltips in here and we will go over what this is. So first of all, we have a country, and the @ syntax allows you to refer to a field within the column data source. We have a field called country names, so we use @country names. We also have GDP, and we refer to @country GDPs, which is also within our column data source. And we use this syntax here to split the large numbers with commas to make them more readable. So if we save that and we go back to the front end, currently when we hover over the bars nothing happens. If we refresh the page, we now get this hover tool which shows you which country and the actual GDP with these commas, making it a little bit more readable because these are very large numbers. So that's the last thing I want to show you in this video. It's been quite a long video, so thank you for watching, and there will be a blog post on this topic as well, so check that out in the description. And the starter code is available, as I said, on GitHub if you want to clone the repository. If you've enjoyed this video or learned anything, please like and subscribe, and we'll see you in the next video.